Hey guys, welcome to AKB and this is Vishnu. In this illustration, an investment corporation want to study the investment projects based on the three lectures: market demand in units, contribution that is sales price minus variable cost per unit, and investment required. These factors are left to be independent of each other. In analyzing a new consumer product for a washing powder factory, the corporation estimates that the following probability distribution. Use Monte Carlo simulation for 10 runs. Estimate the percentage of return on investment, that is ROI, defined by ROI is equal to cash inflow by investment into 100. For each run recommended on optimum investment strategy based on the model value of ROI percentage, use the following sets of random numbers. Random numbers are given for three sections, that is 28, 57, 60, 70, 64, 20, 27, 58, 61 and 30, and 97, 90, 90, 257, 26, 29, 83, 38 and 41. Then 80, 67, 16, 71, 43, 68, 47, 24, 90 and 97 respectively for each of the 10 simulation numbers. Then amount of unit has been given, unit and respective probability has been given. So unit starting from 20, 25, 30, 35, 40, 45 till 50,000, and then respective probability 0.5, 10, 20, 30, 20, 10 and 5%. Then contribution per unit will be 3, 5, 7, 9 and 10, and the respective probability will be 0.1, 10, 20, 40, 20 and 10. Then we have return on investment, which is 170 lakh 15 and 20 lakh and 25 lakh. The respective probability will be 0.25, 0.5 and 0.25. So from here we need to compute the optimum solution for the investment corporation. So what we need to do is that first we need to compute the range, and from range we need to compute the annual demand as well as contribution and required investment from the random number. Okay, for that, first of all, starting towards the solution to determine the cumulative probability distribution corresponding to each of the three factors. Appropriate set of random numbers representing each of the three factors are assigned below. So here we have units and probability. After computing the probability, we need to take the cumulative probability and then the respective range. So range start from 0, and then we need to minus 1 from the total cumulative probability, that is 5 minus 1, which is 4. Therefore 0 to 4 is the probability. After that we have 15, therefore 5 to 14 will be the next probability. In the same way, 50 to 34, 35 to 64, 65 to 84, 85 to 94 and 95 to 99. The same way we have contribution probability. So contribution shall be written, then probability, then cumulative probability as we discussed, it should be added from the previous quantity, which is 0.1, then 0.1 plus 0.2 will give you 0.3, then 0.3 plus 0.4 will give you 0.7, 0.7 plus 0.2 will give you 0.9, 0.9 plus 0.1 will give you 100 or 1. After that we need to find the range. So the range is nothing but cumulative probability minus 1 will be the end part of the range. Here we have 0.1, therefore 0.1 minus 0.01 will give you 9. So 0 to 9 is the first range. The same way here we have 30, therefore here the range ends in 9, therefore the next range will be starting from 10. So 10 to 20, 10 to 29, then after 29 the range starts from 30, so 30 to 70 minus 1 will give you 69, therefore 30 to 69 is the next range. In the same way you need to compute the range. Then we have investment probability. So the investment probability will be written as 0.25, zero point 0.5 and 0.25. Therefore the cumulative probability will be 0.5 for the first section, and 0.5 plus 0.25 plus 0.5 will give you 0.75 will be the second, 0.75 plus 0.25 will give you 1 is the third. After that we need to compute the range. So the end part of the range will be the cumulative probability minus 1. Therefore 0 to 24 will be the first range, 25 to 74 will be the second range, 75 to 99 will be the third range. After computing the range section, we need to analyze the random number with the range to compute the respective units contribution and investment amount. So first random number is 26, therefore the demand will be, the range will be between 15 to 34, therefore the number of units will be 30,000. After that we have the contribution per unit. So the random number for contribution is 19, therefore we need to check the range. So the 19 will be between the range of 10 to 29, therefore the contribution per unit will be 5. Here after that we have investment random number. So the investment random number is 18. To find the range, to check the range, it will be between 0 to 24, therefore the investment value will be 7,50,000. So in the same way you need to compute the entire thing, or you need to go ahead with the entire random number. After that we have simulated return of investment will be demand into contribution divided by interest, investment into 100. So the demand will be 13 into 5 divided by 1750, that is 70,50,000 into 100 will give you 8.75 percentage, right? So rest of the value have been worked out similarly. So this is how it should be computed. So in the first section we have computed 30. 30 is the demand per unit, that is, which means 30,000 into 5 is the contribution per unit into 5 divided by 17.5 would be the investment. Therefore 30 into 5 divided by 17.5, that is 17,50,000 will give you 8.75 as ROI. So in the same way you need to compute it, right? So the above table shown in the highest ROI of 20%, which is corresponding to the annual demand of 35,000 units, resulting in a profit of 10 per unit, and the required investment will be 17,50,000. So when we compute here, when we check here, the most probably or the highest ROI will be over here, which has 35,000 units, right? Yes. So guys, thanks for watching this video. I hope you are clear with this example. If you find this video helpful, please subscribe. Thank you.